Hello, in this video I wanted to show you how to use this project that I've been working on called BifrostJSON. It's an operator that allows you to read JSON data into the Bifrost graph. This allows you to bring more outside data sources into the Bifrost environment. Okay, so let's jump on over to Maya, and the core node that you're going to be using is this one called read JSON. It does have a few inputs which you can read more in detail about over here, but I'm just going to start with going right into a file. I found this file online, which is JSON data that contains information about different Pokemon. The JSON data can be outputted as an amino object or as an amino string in JSON format. The string output option is mainly there so the data can be inspected manually for debugging. You could also output it to Maya in case you want to read the JSON data outside of Bifrost via other methods. Here I'm dumping out the data to confirm we have successfully read the JSON data into Bifrost. If we take a look at the file in the text editor, we can see the same Pokemon data from the file we downloaded online. You'll notice there's a top-level key called JSON data inside the object. All the data from the file is put into that key when outputting it as an amino object. To later access the data, you'll have to retrieve that JSON data key from the object. To access the data, I'd have to chain quite a bit of these get property, get array key, array indexes together. Like first I'd have to do JSON data, which is also pick the right type as an object, and then let's look at the structure again, JSON data, and then it's actually an array of objects. Yeah, I think you get the picture. So it can be quite cumbersome to chain these together, then get from array, and also it just leaves a bunch of extra nodes in your graph. So instead of doing that, I made these little getter and setter nodes. This one is called get with axis expression. It basically allows you to type an expression in here like this, like a bunch of things that you want to get in a row. So things inside curly braces are getting object keys, and things inside brackets are getting array indices. So we want to get JSON data, and then if we look at the structure, it's an array, and we want to get the first Pokemon in the array. And then we want to get the key called name. So let's make sure we're doing that. So we got the first one, which is the 0th index, and then we want the key called name, and then we want the key called English. And the type is a string. Let's make sure we have that. And then we can see here, it should show up if we, Bulbasaur. And if we change this to, let's say, Chinese, then we get the Chinese name. So this just allows you to kind of manipulate and play with the data a bit faster rather than having to chain a bunch of them together. There's also a setter node, which basically does the same thing, except it sets input values instead. You can use the same kind of expression to specify the array index and/or object key. I want to show a practical example of how this could be used. So I've set up a compound which is going to load an asset based on a few input values. I've set it up so I can supply these values in a JSON file, which can easily be swapped in and out to load different assets. You can see here it's pointing to a USD file, which the compound is then internally set up to load. And there's a few other parameters here, mostly just for show, but they do a couple simple things like setting the scale and choosing a variant and things like that. I can pass just a file path into this compound, and then, using that JSON data, it knows what to load. Inside of this Pokemon asset compound, it's reading that JSON file that I just showed, and then there's something here called USD load, which basically just, gets the stage and reads it and does a few other things like picks a variant and stuff. So this compound is just a very simple example of showing how you can kind of use data outside the graph to kind of influence stuff inside. And you can do other stuff, like I added a diagnostic here, which is using the print pack from Roland Ryer. Maybe this could, like, hold some useful information like, oh, this is loading such and such USD file and this animation and blah, blah, blah. And then you can just use one file to kind of configure the internals of your compound, which just, take different inputs as data, but is kind of doing the same thing inside. So like, see, we could, load a different asset. Or this other one, which I've set up to load a different variant based on the key called variant in the JSON file. So like we can see here that if I pick this file, which has a different variant, that then the variant changes. Another use case I thought this could be useful for is like if you have some kind of effect or like simulation where you have certain like presets you want to save, which give the effect a different look, like based on like the parameters inside. Like I have this compound set up to make something that looks like electricity, but a lot of the parameters inside, like the frequency and magnitude of some of this noise, if you change it around a bit, like it can look very different. So I save these like presets kind of into different JSON files to kind of give it different looks, and then I can easily swap between them, like, when I'm trying to execute a shot. Class simulation, for example, is like another classic example of like there's a bunch of different presets you can have to like make certain looks. So like all these parameters, I could make a JSON file and kind of read it in and plug it in and just have something on the outside that I could get different, looks based on, what the parameters are in here. I think one of the main benefits of reading JSON files this way is having it be human readable. We can easily put this under version control and see the differences. You can achieve a similar result with the Bifrost object file format, also known as .bob files, but the main drawback here is that it is a binary format and so not human readable. Bob files, of course, still have their use in other workflows in Bifrost, but if you just need to get a simple blob of data into the graph, JSON can be quite useful. And many programming languages also have libraries for interfacing with JSON, so it opens up the graph a bit more to the outside world and tools. I found this data set from the US government, who provide a large bulk of data sets publicly available online. This one is New York State gasoline sales by year. This data isn't terribly interesting, but goes to show you can now use Bifrost nodes to visualize the data. And again, this chart compound comes from the print pack available from Roland Ryer. This is another one I found, most popular baby names in New York City. This one is a good example of showing like how you can use the visual programming tools inside of Bifrost to also process the data. If we take a look at the data set from the download, we can see that the data is quite dense. To create the chart of top 10 names by gender, I had to process the data and sort it into something more meaningful. The data was organized into many rows, each containing a small segment divided by year, gender, and ethnicity. Using loops and simple logic in Bifrost, I sorted and summed each small segment into a larger value under one name to produce the chart shown. Okay, I think this video has gone on long enough, but before I leave, I should mention that there is a Python build script included in the repo in case you need to build the project for an older version of Bifrost that doesn't have a pre-made release available on GitHub. And yeah, thanks for watching. I hope you find this node helpful for your bifrosting.